As the gas giants are growing larger and larger by sucking in more and more of the hydrogen still present in the outer parts of the solar system, they're not completely alone. Along with the new gas giants are still a great many of the planetesimals that were made up from ice and a few heavier elements present. These objects didn't grow quite as quickly as the seeds for the gas giants, so didn't become planets themselves. They're still substantial objects in space. However, with the gas giants now growing larger and larger, the gravitational force of these new planets also becomes significantly greater. They start to influence the orbits of these dirty little snowballs. From here, there are three likely events for these planetesimals to undergo. The gravitational pull may drag the objects into the planet. As a result, the gas giant will grow larger. They may temporarily be captured in the orbiting the planet for a few million years in a rather erratic as a kind of temporary moon. Alternatively, may pass close to the gas giant where the gravity of the planet will strip away any hydrogen or helium from the atmosphere that the planetesimal may have actually acquired before the planetesimal object is then flung out in a vast elliptical orbit, sometimes coming close to the Sun and then going out further than Pluto. These objects become the comets of our solar system. Because of the age of the comets and the way they were formed, astronomers are very interested in comets because examining the chemical composition of the comets can tell a lot about the early part of our solar system. But whilst all this is happening, the pattern that happened to the star early in its formation is now also being repeated in the gas giants. As the gas giants are gaining in mass, it also means that the gravitational force they exert becomes greater. This in turn means they become denser. As a result, the matter making up the planet is crushed into a smaller and smaller space. However, just as an ice skater is spinning, they pull their arms in, they start to spin faster. The same conservation of angular momentum is happening in the gas giants as well. This rotational movement in the star eventually leads into a formation of a protoplanetary disk as the matter moving around the equator of the star is forced outward like the spinning of a pizza dough. In gas giants, this ejected matter again ends up forming a disk, with some of the lighter gases and ice crystals being pushed a great distance from the gas giants. But not all the ejected material escapes the orbits of gas giants. Some of the denser material ejected orbits relatively close to the planet, and like the early material orbiting the star, this material can coalesce to form the inner moons of the gas giant. Indeed, Ganymede, Jupiter's largest moon, is actually larger than Mercury. These large inner moons tend to have fairly stable, regular orbits, and generally orbit along the same plane as the equator of the parent planet. These gas giants, though, can also capture, at least for a short time in astronomical terms, smaller objects which pass close to them. These can orbit for several million years before being pulled into the gas giant, being flung back out into deep space, or what's known as gravitational tidal forces can cause the moon to disintegrate. These tidal forces occur if the orbit of the moon isn't completely perfect around the planet. The more elliptical the orbit, the greater the resultant force. In addition, as it passes close to larger moons orbiting the gas giant, their gravitational force can also be a major factor. Now, whilst the shattering of a small outer moon be a relatively minor event, it is possible this could have happened to a relatively large moon around Saturn, and the resultant scattered debris is likely to be the origin for the rings around Saturn. Less prominent rings around other gas giants could also happened long ago or from smaller moons. So when we look at how planets formed and how it might form around other stars around us, not only is it likely that they have other planets orbiting them, it's virtually impossible that they don't. What's more, they're likely to have rocky planets orbiting close to the star with gas giants orbiting further out. The most uncertain element is whether the inner planets have substantial moons. However, the exact size and composition of these planets and moons is going to be related to the original composition of the main star. After that, it's just some rather predictable, if complicated, chemistry and physics to decide where the planets are on what they're going to be made up from.